so we're talking about 3D, and does it help? And this is important because that's a question I'm always asked by every couple, and I do 3D always, and they say 3D is a gimmick, you don't really need it. So some of you do not have to be persuaded by me, but I try to persuade the others that it does help, and I want to show you how. So first of all, a few words about the principle. So actually, we scan a 2D scanner is doing a sweep like that, and all the planes are gathered in order to make the 3D. Now, of course, when such a profile is shown to the mother, and let me tell you that not only the mother. Yesterday, I gave a lecture to students in our medical school. I showed them this picture, and I asked them, what do you think about the location of the ear in this picture? And one said low and high and whatever. And of course, none of them actually imagine that it's not an ear, it's the corpus callosum, because it's a middle sagittal section and not an ear. And if the medical student that they are not to know it, so the woman usually will not. So actually we see just a small slice, and of course if there was an eye in this section, then you have the diagnosis of cyclop, of course, yeah, because the midline. Now this is 3D, of course, and you don't see the internal organs, though 3D can be used for the brain as well, but this is in another way in the multiplanar image. So that looks much better. And why should we do it? So first of all, because there is a limited ability in our mind to imagine things, and we face mainly three problems. The first one is that it's very hard for us to understand a picture where it is not split apart. I mean, you don't get the whole picture. You do the ultrasound here and then another plane there. It's not a whole picture. This is one thing. So of course, if this guy would have seen the whole picture, probably it's not exactly what he would think about, because he saw only a very tiny picture. Now, that's a question that I always ask, because this is much easier than ultrasound. And I ask what is in the picture. And why is it easier? It is easier first because it's 2D and it stays 2D. You don't have to make your imagination to think about the three-dimensional fetus. This is one thing. The other thing is that unlike ultrasound, that you have one plane now and the other one here and the other one over there, not at the same time. Here it's only 2D, it's only split apart, but all of us can see all the things in one picture, not at the same time. So can somebody imagine what is in the picture? Well, it's the cat of Van Gogh, if you didn't know. Now, the other thing is that it's even harder for us to understand the picture when the parts are not shown simultaneously. And that's another problem. So I'm going to show you a picture here and a small window that will run all over the picture. And when it comes to the other corner, all of you will see the whole picture, not split apart. I mean, not here section, there section, the whole picture as it is, only that you'll see each time a different part. So when it ends, I'll ask you to tell me what is in the picture. And probably all of you have seen that you just have missed Claudia Schiffer when she was a bit younger than she is today. So until now, we didn't leave the two-dimensional plane. Okay? So here comes the third problem, that it's even harder for our brain to build in our imagination a three-dimensional body from 2D slices. So here is a question for you. This is something that all of you know, and I ask what it is. These are slices, a bunch of things. I go with a slip like that, and I just show you the whole thing in a sweep of 2D pictures. Please tell me what it is.
Broccoli, a tree, broccoli.
Yeah. Some people have good, 3D comprehension. Not everybody has it. Some people do. So let's try another thing. Well, everybody, each one of you know what it is. That's garlic. So, but you see that one or two guys here could guess what it is, and that's a very simple thing, and you know it's about it. So that, imagine a fetus, yeah, which is of course much harder if you want to understand what's there, and unfortunately not all those who do ultrasound has a very good three-dimensional comprehension. Of course the 3D will have one slip and it will solve much of this problem. So that's of course 3D, and by the way, you know, Salman, that when you show the first trimester ultrasound here in Israel, we say, well, because we do it transvaginal, and what have you have to imagine in the 2D, in the transabdominal, it's obvious in the transvaginal. So that's how I do the, you see that's 12 weeks. That's what you see at 12 weeks. If you do, and I recommend that you do it transvaginal. And you know that's, for example, 14 weeks and 3 days. And in a woman would come for the first, we know that we do the first anatomy scan this week, and if you will not do it transvaginal, maybe the woman will ask you, don't you do it transvaginal? Because I know it's much better. And of course it's much better. And let's go on. Of course, 15 and 1 week, and I could go on, and whatever you know. And if you go, this is an older machine, but still you can see very nice. 4D, of course, will let you even see the mimic of the face. Of course, he is not very satisfied, these guys you see in a minute, and these are things that are easily seen on 2D, if you know, of course, how to do it. Now, when you know that our mind has some major limitations, my and yours too, then we go on and see what are the 3D advantages. So here is a 2D image of a 15-week fetus, and just something bothers you in this picture? What is this? That's the umbilical cord. Sure, but look the difference when you see it on 2D, and if you want to see the situation in 3D, I think that reality will be a bit different. Look what happened to this guy. I mean, not that something will really happen to him, but just to show you what is the information that you can get when you see the whole picture and not just a simple slice. So easier detection also of things that can be seen on 2D only is also very important. I'll give here only maybe one case. Let's see, a 30-year-old woman, a mother of 3 male sons. That was very important because she did the pregnancy for a female. And then she came for nuchal translucency at 11 weeks and 2 days. And as I have said before, we do it transvaginally. What do you see here? You see twin pregnancy. But you see any diagnosis about the one on the left here? Now look, you see the whole fetus, because I'm going, look, from one side to the other side, there's not even 1 millimeter of this fetus that you don't see. But still I don't hear the diagnosis over here. Okay, what else you see? Let's try here, the same guy. Now, it can be diagnosed, everything, all the information is here. All right? But only if I show you on 3D, then you see that sirenomelia, which I don't have to explain to you what it is. You see, it was used as a mermaid, you know, by Hans Christian Andersen, and later on, of course, by Walt Disney, only that in the Greek time, they were without any bras. So you can't show it to the kids, so then they change it in the movie. But look now, this is the one that you have seen before, and there's no problem to see that sirenomelia. I mean, when you see one sweep of 3D, and the truth is there. Though I can say once again, it could be diagnosed also in 2D, but it's much easier to show it like this. Now, we did selective feticide, and we didn't do selective feticide because we knew it's going to die, and there will be oligohydramnios, so there's nothing will happen. And so we went to the end of the pregnancy, and of course he died just during the labor, and look what you missed. Of course, all the internal abdomen is outside in this case, but I'm going about to see the legs, so-called, and you see what a terrible thing you have missed just because 2D is much harder. Now, I'm not going to go to talk about Multiplanar because we are late, but this is Sharon, my daughter. Now she's 44, she is 17. And of course that you know that we can take from the 3D volume whatever 2D image that you want, such, of course, could like a bicorneal uterus or septic uterus and so on, and I will skip this because you all know it. So I want to talk about the bones, for example, and here is an example. We usually, not all over the world, but we usually do the biparietal diameter outer inner. Why is that? So in order to show why, I always go to the femur and ask, you see these both femurs, one is straight and the other one is curved. And many times I ask people who do ultrasound every day, why is that? And they have many kind of explanation. Usually none of them is true. Is it osteogenesis imperfecta and therefore it is bowed? So it is not. The problem is that most of the people who do ultrasound themselves, they think that this is the thickness of the femur. However, this is the real thickness of the femur, but because of an acoustic shadow, you can see only the first 3 millimeters and nothing else. In order to prove it, that's how it looks like. You see the straight 3 millimeter here, and the bowed, the curved 3 millimeter here, because our femur is curved on the internal side. Now, that's how it looks like. Now, I can show you, if I'll twist it a bit like this, then you'll see the real thickness over here, as you can see it here. So you understand that actually 2D is very bad for the bone because it doesn't show you the form of the bone, and that's the reason why we do the biparietal diameter here, because we don't know actually where it ends here. So what makes the 3D superior? 2D gives you only a thin layer. So let's look at this bone and see what are we going to see on 2D. So first of all, let's take the animals away. Now here with the bones. Here the transducer, okay? This is the scanning plane. So since you know that you don't see anything but the scanning plane, so I take everything away, okay? Now, we have said that there is acoustic shadow that doesn't let you see the whole bone. So actually you stayed with this. And what I'm asking you is, this is satisfactory? I think it is not. And therefore, if you do 3D, then you can see from above the real form of the bone. And I think that I don't have to let you know that in many skeletal dysplasia, the anatomy is based on the shape of the bone that can be seen much better. This is Marilyn Monroe. So if you take the volume, then you can look at the superficial, or you can look at the bones inside. So this is the surface, and this is the same volume when you look at the bone of the fetus. And look what you can see in 15 or 16 weeks of gestation, beautiful skeleton. Now we have to see what most people are doing today. In order to, if you see long, short, I mean, I'm not talking about genetics now, but if you see short bones, still for the diagnosis, if it's not something that can be diagnosed by amniocentesis, X-ray is the thing that you do. So you make an X-ray of the pregnant woman in order to look at the bones. There are some experts in this field. Now, the problem first is because before 20 weeks, fetal bones are not demonstrated at all because they are not yet calcified in order to be shown, as you need to penetrate the whole abdomen. So what is left? After 20 weeks. Now, what can be seen after 20 weeks? Let's see. So, what you see now is we had Professor Bolkovich. He was an expert in bones, and he had a huge, many envelopes with many cases. And I wanted to get a case, and believe me, for this case, I just came. Can I take one of the cases? He said, take whatever you want. So I went, took an envelope. This is the case. I mean, not something that I chose before. It was a 32 years old woman on her first pregnancy. At first, at 16 weeks, normal bones, 15 weeks, and then later on at 23 weeks, they were short bone. Now the woman was referred to genetic consultation, and this guy who was an expert of fetal and pediatric skeletal malformation, of course told her that we have to do an X-ray. Okay? So remember, please, that X-ray is considered to be still today the gold standard by the expert of fetal dysplasia. So you don't read Hebrew. I will not show you what you wrote. This is Tzvi Borchovich. What I want to show you is the X-ray that I took out from I took it out from his envelope. This is the X-ray of the woman, and I'm asking you, what do you think about the fetal bones? Can you tell me the type of the dysplasia or whatever? So you're looking for the bones, I know. Okay, once again, I want to remind you that X-ray is the gold standard, okay? So, where the fetus, where it is, okay? I'll let you know, is here. But still, some of you are far away, so I'll magnify it. So now the fetus is clearly seen. Can you see something? No. All right, I'll help you. Here, I don't know if you see it over there. Yeah, you can see it there. Here, there's a skull. You see a bit here and a bit here. Okay? The other one, if you see some lines here, these are some ribs. And ladies and gentlemen, this is the only part of long bone that was seen in this picture, and on the basis of this X-ray, this guy said that the bones looks okay and no skeletal dysplasia is suspected. Okay? Now, of course, that's the X-ray after after the abortion, because we did find that it was problematic. I don't want to get into it, but just I wanted you to compare it to the skeleton of a fetus at 16 weeks of gestation, when X-ray is not available at all, so you will understand that these things, three-dimensional ultrasound, will help you very much. Now, another advantage of the 3D is the detection of minor facial dysmorphism, and of course, that will help you to make many diagnoses. Now, why it's so important to keep as possible to the real image? Because our mind, as I have said before, is very limited, and not only that it cannot switch from 2D to 3D, even the orientation of a picture, if it's upside down, still we don't see the truth. So I have three daughters. This is one, she studied medicine now second year. Here she is, she was 14, and her name is Iris, and the only thing I do now is that I put the picture upside down. Now I like to play with Photoshop, so with the aid of Photoshop I added some dysmorphic signs to her face. Now the only thing I'm going to do now is to take this picture and again upside down, and I want to ask you whether your impression from the face here will be the same as you will see the picture now. And I think that you can imagine that there is a great difference, and the only thing that it was upside down, that is all. Okay? I can take my other kid. Here you see, maybe someone can even say that she's nice where she is here. However, that's what happens when it's upside down. That's, by the way, on her wedding. She was 36 with the red wedding dress. I don't know if you've seen one like this before. Okay, here we are. So, since our mind has such limited capabilities, the conclusion is that the more close we will be to the reality, not on the orientation, on the modality, 2D, 3D, we should improve our diagnostic capabilities. And I give you an example. You know, Peter Pan, I like Peter Pan because that was the first movie that I ever seen. I was 4 years old. It was in 1954. Now you can see that I'm 68 now, and that's the first one that I've ever seen. Now I don't know if you have ever noticed that this guy here, Michael, actually has an achondroplasia. I have no idea why Walt Disney did it here, but if you look at him, you will see first of all the relation between the head and the rest of the body. If you compare to John, you see the short limbs. You can see the trident hand that he had, all the signs. This guy was quite accurate. You can see the frontal bossing, and you can see the cell nose that this guy had. So these are the achondroplasia. Okay, and the problem is that the discrepancy between the normal and the abnormal length develops mainly in the third trimester. So frequently we are in a difference, it's small difference, it's a gray zone. Is it, come in 2 weeks, come in 1 week, we should see once again. And of course it doesn't make a very good mood to the woman. And the abnormal ultrasound finding in the fetal phase could have helped us to do the diagnosis much earlier. So the syndrome, of course, is autosomal dominant. However, 50% of the achondroplasia is a new mutation. Therefore, usually you do not have any history. It comes as a surprise. Not 50, I'm sorry, 80% of them. So that's the case. Salel is sitting here. You also know the woman he saw in one of the examination that she came to me in a 29 week of gestation, and 4 weeks she's being followed due to deceleration of the limb growth. The findings were inconclusive for diagnosis of skeletal dysplasia, and therefore she was asked to come one. So you can see that the biparietal diameter, fetal, that doesn't matter. I just want to show you the femur, and this is my examination, and the rest are previous examination. So I want to see what's the trend, and you can see also here the tibia. Okay. However, it was not because if this is the 5th percentile, 5% of the population will be here. So if you have to kill 5% here, maybe the 5% here, you'll be left only with 90% of the population. That's not good. So in case of skeletal dysplasia, she would like to terminate the pregnancy, but can we conclude that it is? So no. I mean, it depends, but what I'm saying is that it could be done much earlier if we looked at the face, and by the way, also the fingers. You see, the fetus did have trident hand, as you can see here, but what I want to show you, also short limb that you can be impressed of, that's, you see 28 week of gestation, maybe even the short head. But I want you to look at the face. Look at the face in 2D. Well, can you recognize the typical nose of the achondroplasia? I think not, okay? Because that's 2D. It's hard to decide anyway. So, just I want to show you that, you see, the angle here is almost 90 degrees. If you, not exactly, if you compare it, for example, for this angle, for this normal fetus, the angle is much bigger. However, would someone approve termination of pregnancy because of this angle that I've just showed before? And of course the answer is not. However, if you do the 2D, there's no doubt that you have the saddle nose and also the frontal bossing of the achondroplasia, and you could do it much before, as we did just after this examination, and of course it was. Okay, so another advantage of the 3D is demonstration of fingers anomaly. So this in 16 weeks of gestation is very good because usually it's not clenched, the hand is not clenched, so you can see very nice. However, later when the hand is clenched, then you cannot see the whole fingers in one plane usually, and that's a problem. So clenched hand of trisomy 18 will not be very easy to be diagnosed on 2D. You see, they have clenched hand, the second finger override the third finger, but it's not very easy to see it only when you do 3D, and that's very obvious. Of course, we terminated this pregnancy, of course, and it also be very good to do 4D, and then you see that though most of the time it's clenched, it can easily show you that it's not the situation. Now, syndactyly, for example, you see, that's a hand with syndactyly. Now, what is the problem? The problem is that the diagnosis is difficult in 2D. When the hand is normally clenched, usually the fingers are attached to each other, and the absence of space cannot usually be demonstrated. Okay? So, we have to wait. Once again, we have to wait for the short moment of opening, and then maybe when it will open, the fetus will open its hand, maybe we shall miss the location of this hand syndactyly because we don't know where it's going to go. Okay, but with 4D, it's very easy because we just put the hand in the volume and then we wait. Now, I want you to see that when this guy, you see, open his fingers, the fourth and the fifth fingers stay together. Now, try to do it. You can do it. But if you don't try hard, when you'll open it, you'll have all the spaces open, okay? And it didn't try just for me, so easily you can see that there is a syndactyly between the two fingers. Okay, now the posterior palate, is almost taboo in 2D ultrasound until the equal side hand came and helped us with this. But just I want to show you on 3D, when you just make a section like this, you cut away all the from the plan and down, and then you can look at the palate very well and see it. Now, I know, and you know, all the literature that was about it, which I very much don't like, because you can do it only when they open the mouth and there is water between the tongue and the palate. Because unless many of the pictures that I saw in papers actually are cut through the tongue and not the real palate. Okay, but you can see it up. Look, that's a case I had recently of a true knot in the umbilical cord. Somebody who's very good in 2D will see it as well, but look how nice you can see it if you do three-dimensional picture. That the same one that I did is obvious. I mean, and this is when you took this guy out. Now, the last thing that I want to talk about is the HD Live, that probably you know, is the addition of shadow to the volume. And why does it help us? The virtual light source can be located at any angle relative to the ultrasound volume. It can be offline or online. You can even come behind. Now, here I want to show you, for example, that I move the source light from every direction that you want, even trans-illumination, as you can see. And why is it good? Why is it good? Does it have a clinical value? It does. Imagine that there is a notch here. Now, if usually in the usual three-dimensional ultrasound, the light comes from the place where the transducer is. Okay. Now, here in the bottom, since the light comes from here, if you will look from above, it will not be very different from the rest of the thing because it's lighted as well. However, if you put the light on the side, then you'll have darkness here, and then if you look from above, it will seem more, it will emphasize the fact that this is different from this, and there is a notch here. So look at that one, for example, with a cleft lip, and you can see that sometimes you can hardly see the cleft lip. Only when the shadows come from the side, this is very easy to see it. Okay, and sometimes you don't see it at all. All depends on the direction of the light. So look here, how very easily you can see it, and here it can only almost not be seen just because the light comes from a different source. This is the guy that we hear about it. So actually, look at this one. We like to see the eyes of Down syndrome, for example. Now, both pictures are the same volume, exactly. However, you don't see you can see the fissure of the eyes here, and you don't see at all here, only because the light that I put was in a different picture. And about this and Down syndrome, I must show you the beautiful picture of Benoit, that this Down syndrome, you see also the same volume over here and over there, and another one of Benoit as well, that you can easily see that it's the Down syndrome just because you did. So 3D, the thing that I'm not going to talk about, involving many new modalities, and I show this picture to see all the things that Simcha Yagel is going to talk about, and so about rendering, MPR, tomography, inversion mode, B-flow, 3D Doppler, and so on, and I will not talk about it. That I will leave to Simcha Yagel, and I thank you very much.